Hello student, welcome to the classical mechanics course. In last lecture we end up with the first module of our classical mechanics course, which was the system of particles. So in that we thoroughly gone through these Newton's laws of application and its different applications. At the end we discussed what are the constraints on the system of the particle through which Newton's law is strictly obeyed. Okay, so during that we see these different conservation laws: conservation of energy, conservation of linear momentum, conservation of angular momentum, and each conservation law has its own areas of the application, or it obeys under the certain circumstances. Okay, so this was the topic where we discussed the basic pillar of the classical mechanics, we can say that. Okay, so the Newtonian mechanics we thoroughly discussed in the first module, and its application also discussed in the first module. In the second module, the name of the second module is the motion in a central force field. Okay, so this is again the quite interesting topic as far as this classical mechanics or the mechanics parts is concerned. Okay, so what is meaning of this central force? So before going into that detail, let us go through this. What are the different natures of the forces observed in the nature? Okay, so we discussed we know the several forces exist in the nature. So if we categorize such kinds of the forces, so each force can be categorized in the different field depending on the areas of the interest, depending on the applications of the interest, depending on the nature of the forces. Okay, suppose if we categorize those forces, basically in the nature there are several basic 5 forces available: gravitational force, electromagnetic force, nuclear force, weak force, strong force, and many more. Okay, so those are the basic forces which occur inside the nature, or the every action inside the nature we can categorize, we can observe these action reaction forces just because of these 5 forces. But suppose if we categorize those forces based on its nature, based on the force, how this force supposed to be exerted on a certain body, on a certain particles, or in principle, if you follow these guideline for certain applications of the force, you will find what is the nature of this force. Okay, so if you go beyond this what exactly the force and what is the derivation, what is the formula for that force, if you go beyond the nature of the force, you will come to know that the forces can be categorized in 2 main topics. One is central force and second one is a non-central force. So our topic is something related to the central force field. Okay, so how this particle is supposed to behave if the forces are central force. Okay, so what do you mean by central force? Okay, so the quick or basic definition of the central force is that the force which is directed toward a certain point or away from a certain point. So you can say that how we can categorize, how we can analyze such kinds of the forces. Let us take an example of this gravitational force, or take an example of this Coulombic force, the force between 2 charged particles, or if you consider the gravitational force, which is the force between 2 massive point-like object. If you recall the gravitational force, how these Newton suggest in its gravitational force, it is the force between these 2 point massive body. So this is point massive body. So how to define this point? Basically, when you call the point body or point charge, how to define this point charge? So this is a dimensionless quantity. Okay, so if you see this point, since there is no such dimension assigned to this point, it is a single point with 0 dimension, we can say. Okay, so if you consider such points and if you correct this point with the what are the different forces acting on such points. Suppose if you take a look, suppose if you have a charge q and another charge is q prime is in the vicinity of this charge q. So force experienced by the charge due to this charge q is, okay, so this point joining these 2 forces, these 2 charges basically denotes the direction of the force. Okay, so if you change the nature of the charge, if instead of this positive charge, if I replace it with the negative charge, so direction of the forces again changes. But the crucial part is this force is only the direction dependence, only the there is no such theta dependence on that. Okay, so if you have this plus q charge, this plus q charge, so the force is repulsive force. So in that case, direction of the force is away from the single point. Okay, I am talking about this central force. It is the force away from the point or toward the point. If you consider the both charges are positive, in that case force is repulsive. Okay, and if I consider this as a negative charge, in that case force is attractive. So in that case force is directed towards the point. Let's say if you consider the point A, so force is directed towards the point A. Okay, similarly if you consider the gravitational force, so the basic fundamental definition of the central force is the force which is directed toward this point charge, or sorry, which is directed toward the certain points or away from that certain point. So this is the central force field. So what are the different examples of the central force field? Gravitational force, since we are taking into consideration those massive particles are the point-like particle. Okay, so in that case this gravitational force between two massive body is again the central force. It again directed towards this point-like mass particle. Okay, so again Coulombic force due to two charged particle, and there are n number of applications we can say which is the result of the central force field. So how to locate, how to write the central force field? So central force field can be written as F bar, since this is a force, so it can be represented some F of R times n cap. F of R, since force is vector quantity, it is denoted by this vectors bar denoted over the symbol F. F of R is the magnitude of the force, and n cap is the unit vector directed along the force, directed along the force direction. So from these F of R is equal to F R n cap, since n cap is a unit vector. So from this basic, this is just a formula for this central force, what should be the nature of the central force. So from these formula, from these F of R is equal to F of R n cap, can we define whether force is attractive force or repulsive force? Yes, obviously we can write these, whether based on this F of R value we can again categorize whether force is repulsive force or force is attractive force. Suppose we have this F of R is less than 0, since in that case force is attractive force, attractive central force, attractive. And if F of R is greater than 0, since in this case when F of R is negative, in that case force is attractive. When F of R is positive, greater than 0, so that means it is positive, in that case force is repulsive. Okay, so from the value of F of R we can categorize whether force is attractive or force is repulsive force. Okay, so this is about these central force. This is a basic definition of the central force. So in many of the exams it is asked that which of the following force is the central force. So crucial point which you should remember that about the central force is only depends on the distance between 2 points. It is not depend on the theta and phi values. Okay, so the things which shown in this formula is only r dependence. If you express this force in again the cylindrical coordinate system or again xyz coordinate system, since the force is only depend on the spatial coordinates, not the direction dependent, not the direction wise it is dependent. So from that we can analyze these central force is depends only on depends only on distance 2 point. Okay, since it is only depend on the r value, there is no theta and phi values. Okay, since we are writing this in the spherical polar coordinate system, so we can again represent this f of r in terms of the Cartesian coordinate system or cylindrical polar coordinate system. But you should remember the central force is only depend on the distance between these 2 points. Okay, since it is not depend on theta and phi. Basically it is not depend on the theta and phi. So if question comes in the example, which of the following is the central force, so just look at the dependence on the central force. If given force is depend only on the r, it is central force. If there is an inclusion of theta and phi term or direction dependent term, in that case the force is not the central force. Okay, so this is all about the central force, and the central force again represented in the three-dimensional geometry by the plane curve. Okay, or the central force can be represented in the single plane, you can say. Okay, so those are the areas of the application, or those are the properties of the central force field. Okay, so in the next we will start this equivalent one body problem.